Welcome to the topic on elements, compounds, and mixtures. In this topic, we are going to take a look at what's an atom, and then about what are elements and what are compounds. We will also learn about what is a mixture and the different type of mixtures that can exist. Then, we will learn about the properties of pure substances, which is essential for us to be able to identify if a substance is pure. We will then move on to metallic and non-metallic elements, as well as learn about alloys as a mixture of metals. We will see what effects chemical reaction can produce in comparison to some simple physical mixing, which produces mixtures. Lastly, we will look at the reversible and non-reversible changes that can happen to matters or the substances. What is an atom? An atom is the simplest and indivisible particle of an element. That is the definition of an atom, and you must remember it. Every one of the substances we see or exists are made of millions of atoms that may be bonded together. If all the atoms in the substance are made of or contain the same type of atoms, we would call the substance as an element. So, what is an element? An element can be defined as a substance that is made up of atoms of the same type. Some examples of elements would be carbon, hydrogen, silver, iron, oxygen, etc. You should have seen a periodic table of elements. The periodic table of elements shows all the elements known to mankind till today. It's a very useful tool for identifying elements and also has a lot of other useful information, which we will learn about in the future. Elements can exist as single atoms or a cluster of atoms called the molecules. Here is an example of a monoatomic element. Examples of elements that are monoatomic are those found in the last group of the periodic table, which is called the noble gases group. Examples of monoatomic elements are helium, neon, argon, etc. This diagram shows diatomic element containing two same type of atoms sticking together in a cluster. Most gases, such as oxygen, nitrogen, chlorine, hydrogen, fluorine, and so forth, exists as diatomic elements. If we have three atoms of the same type bonded together in a cluster, we would call them as triatomic element. That's a macromolecular element. As you can see in the diagram, there are thousands and thousands of atoms of the same type bonded closely together. The word macro means big or huge. Therefore, we call these elements as macromolecular element since a huge number of same types of atoms are sticking together. Examples of macromolecular elements would be like carbon, which is also called the diamond. Most of the metallic elements such as iron, zinc, lead, silver, gold, etc. are also macromolecular elements. The word mono means single. Since this element exists as single atoms, we call them as monoatomic element. Di means double. Diatomic elements exists as a cluster of two atoms per molecule, and hence the name diatomic. Macromolecular elements, as we have mentioned earlier, contain many atoms closely packed together. We can recognize the elements by the use of capital letters in their symbols. Their symbols are either written with a single capital letter like H, N, C, O, etc., or they have two letters in their symbol. In two-lettered symbol, the first letter should be capital and the second letter should be a small letter. For instance, calcium is written with a capital C and then a small letter A. Some elements are represented by the first two alphabets of their names in English, such as calcium with C and an A, argon with an A and R, lithium with an L followed by an I, and beryllium with a capital B and a small e. Take note that in these cases, only the first alphabet is capital and the subsequent alphabet is a small letter. Some elements are represented by alphabets of their names in other languages such as Latin or Greek. For example, sodium is represented as a capital N followed by a small a. It comes from the word natrium. Potassium with the symbol K comes from the word kalium. Name of iron is derived from the word ferrum, and hence having a symbol of capital F and a small e. Symbol for copper is Cu. It comes from the word cuprum. Lead with the symbol of Pb comes from the word plumbum. Multiple elements can have the names starting with the same alphabet. Hence, we must be careful to remember the symbols correctly. As an example, some of the elements whose names start with the letter C are carbon, which has a symbol of C. Calcium has a symbol of C and A. Chlorine is written as Cl. Copper is written with a C and a U. Cobalt with a capital C and then a small letter O. The metal cadmium is given the symbol of Cd. As we can see, all these elements start with the letter C, so we have to carefully remember the correct symbol for the element in order not to make any mistakes. Another important point that we must take note of is that we must remember to write small letter which is distinguishable in size from capital letters. Ugly handwriting can often lead to misinterpretations of the substance being written. For instance, capital C with a small o is the symbol for cobalt, which is an element, while a capital C with a capital O becomes the chemical formula of carbon monoxide, which is a compound. The periodic table. The periodic table of elements is a very useful tool for chemists. It gives a lot of useful information about the elements to a chemist. Dmitry Mendeleev, a Russian chemist, was the first one to lay the framework for the periodic table of elements in the year 1869. The periodic table of elements classifies the elements into metals and nonmetals. The elements to the left of the zigzag line shown are metals, while those to the right of the line are nonmetals. As we saw earlier, elements can be broadly classified into metals or nonmetals. Metals usually have 1, 2, or 3 electrons in the outermost shell of the atom, with the exception of hydrogen and helium, which are actually nonmetals, but have 1 and 2 electrons in their valence shell. Metals usually lose electrons to become a positively charged particles, which are called the cations. Metals are also good conductors of electricity in solid or liquid state. This is because they have electrons that are free to move about to conduct the electricity. Mostly metals are in solid state with the exception of mercury, which is the only metal that exists in liquid state at room temperature. Let us now learn about compounds. What is a compound? A compound is a substance that is made of atoms of different types that are chemically bonded together in a fixed ratio. Remember that for a substance to be called a compound, it must be made of atoms of different types coming from different elements. These atoms must be bonded together by chemical bonds. They must also bond in a fixed ratio of the atoms. For instance, for water, it must always have 2 atoms of hydrogen that must always be bonded to 1 atom of oxygen in every molecule. Carbon dioxide has an atom of carbon always bonded with a couple of oxygen atoms. Ammonia has a nitrogen atom bonded to 3 atoms of hydrogen to form the compound. Ethanol has atoms from 3 elements. Carbon, hydrogen, and oxygen combined in the ratio of 2 is to 6 is to 1. Another example is glucose, in which 6 carbon atoms are combined with 12 atoms of hydrogen and another 6 atoms of oxygen to form a molecule. Therefore, remember that a compound must be made of atoms of different types that must be chemically bonded together, and the atoms are always in a fixed ratio. The compounds can be diatomic, containing 2 atoms of different types bonded together in the ratio of 1 is to 1, such as carbon monoxide or nitrogen monoxide gases. Compounds such as water and carbon dioxide are triatomic compounds. As we can see, there are 3 atoms that are bonded together in each of the molecules in a triatomic compound. Thus, a diatomic compound contains 2 atoms per molecule, and a triatomic compound contains 3 atoms per molecule. There may be bigger molecules that may contain larger number of atoms per molecule as well. As long as they contain different types of atoms that are bonded together in a fixed ratio, they are called compounds. When we refer to a substance as a compound, remember that it must have chemical bonding. Otherwise, they are simply considered as a mixture. Though these 2 diagrams look similar, take note that in the compound, the atoms are sticking together and are known as being bonded. In a mixture, the atoms are not bonded and are simply mixed together. Well, what is a mixture? A mixture is made of different types of elements and/or compounds that have been just physically mixed together without bonding. Mixtures can be separated easily since they are not bonded with each other. That's how we can define a mixture. When we say mixtures, we can have a mixture of elements where each component consists of an element mixed together to form the mixture. In this diagram, we can see a diatomic element mixed with a monoatomic element to form the mixture. We can also mix an element with a compound to create a mixture of elements and compounds, such as the mixture shown in this diagram, where a monoatomic element is mixed with a diatomic compound. We could also create a mixture of compounds where each substance is a compound like that shown in this diagram, where a diatomic compound and a triatomic compound are mixed together without being chemically bonded together. Another interesting type of solid mixture are the alloys of metals. Alloys are mixture of metals that are melted, mixed together, and then allowed to solidify. Thus, they are just mixture of metals that are mixed in various ratios to create the property needed for the application. Alloys have far superior properties compared to its elemental metals that makes them. Some examples of alloys are like brass, duralumin, bronze, steel, and so forth. Brass is a mixture of about 66% of copper metal mixed with about 34% of zinc. Compared to both of the elemental metals, brass has excellent malleability, machinability, corrosion resistance, and strength. Duralumin is another alloy made from copper and aluminum, which accounts for about 95% of the alloy, as well as a small percentage of magnesium, which is about 1% of the alloy. Duralumin can withstand high-pressure applications such as pressure cookers, aircraft body, etc. Mixing can result in a change in the substances being mixed together. These changes can be as a result of a reaction between the substances, in which case we would call it as a chemical change, or it could simply result in a physical change which could be easily reversed. Physical changes are usually easily reversible changes. Examples of physical changes would be like freezing, condensing, evaporating, subliming, dissolving, etc. Chemical changes are usually irreversible changes. It also involves a huge amount of energy changes, which results in the formation of completely new substances with totally different physical properties. Burning a piece of paper changes it into an ash, which cannot be reversed back into a paper. Burning or combustion is an example of a chemical change or an irreversible change. Other examples of chemical changes are like corrosion of metals such as rusting, oxidation of sugar into carbon dioxide and water during respiration, or the electrolytic splitting of water into hydrogen and oxygen gas. That's the end of this lesson. Hope you have enjoyed learning this topic. Till we meet again, have a great day from all of us at Donison Dean Research Center, Singapore.